To get the integral of tan, you're going to want to first replace the tan with sine over cosine. And then we're lucky that we can let the bottom be our u, and then our du is going to work out nicely, because what's the du? Well, it's going to be negative sine x dx. Now that's really close to sine x dx. So all I need to do is just change the sign here to a positive, as long as I change this to a negative, and I find out that sine x dx can actually be swapped out with negative du. So I'm going to put a negative du where I see that, but then I still have to put over cosine x. But instead of writing it as cosine x, I'm going to remember that I wanted to write cosine x as u. So now it's negative du over u. All right, so we're close, but now I'm going to pull out that negative, and I'm also going to rewrite it as 1 over u du. But now, integral of 1 over u, well, that's always ln absolute value of u. And plus c, and I can put my u back in there. Now, technically, we could say this is the answer. It's just not necessarily what you're going to see on formula sheets. So what I'd recommend you do is you take this negative and you bring it to the top. Now, you might be like, what do you mean just put a negative? You're not allowed to do that. So instead, we're going to write this as a negative 1, so we can bring it up top as a negative 1. That is a rule of logs. So we now have ln absolute value cosine x raised to the negative 1. Okay, but we can skip a little bit of steps here, and I'm just going to let you know that you actually can put that negative 1 inside with the cosine. So now you have absolute value of cosine x raised to the negative 1. Now, when you raise something to the negative 1, that's the same thing as putting 1 over that thing. But what is 1 over the cosine? Well, it's actually just the secant. So that's it. We are done here.